So let's continue with the probabilistic sampling methods. If you haven't seen the first probabilistic sampling methods video, go back and watch that one first. So we have simple random sampling, systematic random sampling, and the next is stratified random sampling for our probabilistic sampling types. So stratified random sampling, essentially it uses some kind of characteristic that is determined to be a relevant and important characteristic of the population that's sort of going to affect the representativeness of the sample and whatnot. So it uses some characteristic of the population to make that sampling process more efficient and to make sure that we're getting an adequate sampling of the subgroups. So it kind of is a way to almost force representativeness of at least one characteristic, or you can do it for more than one, but it's simplest to do it with just one. But it's like forcing representativeness of at least that one characteristic of the population to make sure that it's in a proportion that you want it to be. So there's two steps to do this. So you would first distinguish all the elements in the sampling frame. So again, you have to start with a sampling frame, the list of all the people in your population, you would want to distinguish all of the people in the sampling frame according to whatever that relevant characteristic is. So that characteristic is going to form what we call the sampling strata. And so, for example, I might want a certain demographic representation. So whether we're talking about like age or race or gender or socioeconomic status, that might be the characteristic. Or if we're looking at an offender sample, maybe we want like offense types or offender types, and we want it in a certain proportion. Or like risk level, we want a certain proportion of low risk, medium risk, and high risk offenders. So that characteristic then is we have to go through our sampling frame and make sure that, say we're going with risk level, our entire list of offenders, our population that we're going to draw our sample from, we have all of the designation of what their risk is, whether it's low, medium, or high. So then that characteristic is going to form our sampling strata. And so then each element has to belong to one of those stratums, but only one stratum and only one stratum. So it has to be, they have to be mutually exclusive and exhaustive. So you can't have an offender who's like low/medium risk. That's not going to work for what we're doing. They have to be low, medium, or high, and everyone has to fit in one of those three categories. So once you have your sampling frame in a way that you have your entire list of your population and every element on that list, their risk level. Then you're going to sample elements randomly from then within each strata. So you've got multiple strata, and you have, so we've got all of our high-risk offenders, all of our medium-risk offenders, and all of our low-risk offenders. And then we're going to do random sampling from each of those three groups. But we're going to know we want, so many high-risk, we want so many medium-risk, we want so many low-risk to come up with our final sample. So we're just going to choose to make sure we get the right number of each of those from that, based on that characteristic of risk level. And there are kind of two ways you can do this. So you can do proportionate stratified sampling, where you basically are trying to make it so that each strata is represented in proportion to its size in the population. So this is basically to make it so that your proportions remain the same. So if we were looking at offenders, then, if we have risk levels, then probably to have a proportionate stratified sampling, we would have a lot fewer high risk. Most would be low risk. Our biggest group would be low risk because most offenders are low risk. We would have a medium size group for medium level risk, and our smallest group would be high risk because in the offender population as a whole, high risk offenders there's less of them. So if we wanted a proportionate sample, then we would make sure we got less of high risk and sort of in the middle for medium, and most of our sample would be low risk. However, sometimes you want disproportionate stratified sampling. So you are intentionally changing the proportion in your sample compared to the population. So you are intentionally making it so that on that characteristic, it's actually not going to look like the population. You're going to oversample certain groups and undersample certain groups. And so you still know the probability of selection. So that doesn't change. Well, I mean, that probability will change, but the fact that you know it doesn't change. But it's going to become so that it's unequal between strata. So, for example, if we want that risk level and we're like, well, we don't want like that really small number of high risk, though, we want more of those high risk offenders because we think they're more interesting and maybe they have more things to say about whatever it is we're asking about. And so we're going to actually oversample those people. So they're actually going to have a higher probability of selection because there's fewer of them in the population compared to the proportion we want in our sample. So there's say we have like a population, a target population with our sampling frame of like 1,000 offenders. Maybe 100 of those are high risk. And if we wanted a proportionate sample, then we would want, say if our sample is going to be 100, then we would want 10 of those in our sample. But if we want disproportionate, then we're going to be like, no, we actually want like 30 of them in our sample. So now in that 100, instead of having a 10% chance of being chosen, they now have like a 30% chance of being chosen. So they have a higher likelihood of being selected to be in our sample. Whereas the low risk offenders now, say that's like half of the population, they had like a 50-50 chance of being, or rather they would actually have, they would make up 50% of our sample in a proportionate sample, and so it would still be a 10% likelihood. But now if we're actually lowering that, so they're not actually going to take up half our sample, maybe they're going down to like 30% of our sample or something, or maybe 40% or 35%, then their chance of being selected is now going to be lower than it would have been in a proportionate sample. So we're actually, because there's a whole bunch of them, there's like 500 of them, but now we're only choosing like 35 instead of 50. So in disproportionate sampling, we still know the probability of selection for each group. It's just going to be different for each group, and some groups are going to have higher and some groups are going to have lower chances. So typically you want to use this if you want to make sure small groups are included and have sort of enough of a voice. So it could be something like our high-risk offenders, we're just really interested in them. Or say we want an equal representation of all political views, but there are very few like true far right or true far left, and we want to make sure we actually get them in our sample. We might oversample those far left and far right groups to make sure they're in our sample. So this would be sort of a way if you want to design your sample for a specific purpose. And so you would have to have a reason as to why you would want disproportionate sampling, but you can justify it as long as you know what you're doing and why. And there's a reason for it, then it can definitely make sense. So then multistage cluster sampling is basically like what it sounds like, where you choose things in 2 or more stages. So you have at least 2 stages, it could be more. But essentially, so there are 2 kind of steps that you would take to get your sample. And the first stage is to figure out your clusters. And so clusters are basically groups of elements in your population. And so each element, again, is in one and only one cluster at a time, so it's mutually exclusive and exhaustive. But you're basically clustering your elements, and this is not the same as creating strata. Typically, this is the most often that this kind of sampling is used is when we're clustering geographically. So you would have geographic locations, and so then you would have maybe within a state, you're looking at counties, and so each county would be a cluster. And then you would randomly select counties that you're going to go to. And then within each of those counties, you're going to get a random selection of the people you actually want to talk to. So often this kind of research is done, and typically, again, it's done geographically because you can only travel so much to gather data, and you want it to still be random, but you don't want to have to like randomly go all over the state to make sure you tap into all the different possible counties. You want to make it so that it's going to be easier for you to collect your data, it's going to be more efficient, but it's still going to have that randomness element. So the way that this kind of looks like for best results, you want the most number of clusters with the least number of individuals within each clusters. That makes sense for you to do, and that that would be still efficient to gather that data. So, and if you think about it, because we'll go to extremes, if you were to go to one state and say, well, we're going to pick one county, then yeah, it's going to be a random selection of what county that is, but now that's the only county you're getting information from. Whereas if you're like, well, we're going to randomly select like 10 or 20 counties from a state, then now it's still that randomness, and you still don't have to go to every county in the state, but you're getting a more representative sample, and then you're going to take less people from each county to get your final sample, but you're going to have a better sample that's more representative and certainly kind of more random. So typically you want to do this when the sampling frame is either unavailable or it's too expensive to cover the entire sampling frame. So this is why, like, geographically, yeah, we may have a list of everybody who lives in the state, but maybe we don't want to go all over the state if we don't have to, and we want to just sort of at least zero in on certain counties we want to go to. So this is kind of, I like this picture representation because it kind of shows that, so say we have 9 clusters here, and so we're randomly going to choose 3 of these clusters. And so we kind of get still get a spread of, representation from the clusters. We don't get all clusters represented, obviously, but we still get that randomness. And then within each cluster, we want to choose 4 people. And so we're picking 4 at random from each one. And so it's going to be different randomness within each cluster. And so we still have that randomness element. So anytime we're doing probabilistic methods, randomness is the key. It's just that we have the various different types of methods that would sort of make things easier, either in terms of choosing from your sampling frame, which would be the systematic random sampling, or in this case, sort of narrowing it down so you don't have to cover as much, but you still maintain that randomness. Or if it's the stratified random sampling, then it's because you want a certain representation, and you're kind of almost cheating to make sure you are for sure getting the right proportion of a specific characteristic. But anytime we're doing probabilistic, randomness is the key. So at some point there's that randomness element that makes it so you still have that probabilistic technique where you know the probabilities, but they may change, but you know those probabilities and you have randomness. That's the key.